All right, now let us draw the small signal equivalent circuit of the common emitter amplifier, this basic one, and find the necessary variables, V, R in, and R out, or parameters. So what you have to do, label your transistor points, C, B, E, and we have to short or deactivate the source, the voltage source, set it to ground, and capacitors, all capacitors will act as open circuit. So our circuit will be like this. So we have DC is shorted out, this is RC, this capacitor is shorted out also, so it will act as open circuit, that is RL, this is V out. Then we have R1 shorted, the source is shorted there, R2, then the coupling capacitor is shorted out, and this is the input Vin. So the input resistance would be Rn from here, the output resistance R out, and the gain will be V out over Vi. So this we call it AC circuit. AC circuit. Now, to do the analysis, we have to replace the transistor by its equivalent circuit, small signal equivalent circuit. So in this case, since the emitter is grounded, it is easy to use the bimodal of the transistor, right? So if we look at the transistor, we can just replace it with its equivalent bimodal circuit. So this is the emitter here, this is the base, and this is the collector. This is called R bi, the volt here is VBE, and this we can call it GMVBE or beta IB or whatever you would say, right? And now we have only the transistor. So this is the transistor, and we replace it with this. So we can just make a circle here, like, you know? So this is my transistor. Now, I have to connect now the rest of the circuit. So I'll start with the emitter. The emitter is grounded, so we ground it. Then from the base here, we have R1 and R2, they are in parallel, so we can call this combination as RB equal to R1 parallel with R2, two resistors together here, right? Then we have here, we have only the source, that is VI, ground, we don't have a RS here. If there is RS, then we have to include it here. But RS will not be part of the input resistance, you have to keep this in mind. Now from the collector side, we have RC to ground, RL to ground. So this is RC, and this is our load, which is RL, that is V out. So if I label the input resistance should be Rn after the source, and the output resistance should be before the load, that is R out. Now we can do just simple circuit analysis, right? Where we can find a relation between V out and Vi. So if I combine these two resistors in parallel, I'll call it RL dash, let's say. So RL dash is the parallel equivalent, RC in parallel with RL. And find V out. So we can say this current is IC, V out will be the combined resistors RL dash multiplied by IC, but be negative. So we can say V out equal to minus IC times RL dash. So that's equation number one. So IC, you can think about it as, or you can just replace it by GMVBE. So we can say this is equal to minus GMVBE times RL dash. So that is equation number one. As you can see, we have V out as a function of VBE, but we don't want that. We want V out as a function of VI. So we have to find the relation between VBE and VI. As you can see here, VBE from here to ground is the same as VI. So we can just simply say, but VBE equal to VI, that is equation 2. If we sub 2 in 1, then we have V out is equal to minus GM VI RL dash, and hence the gain will be AB V out over VI equal minus GM RL dash. So that is the first thing you have to do, is to find the gain, right? Now, as you can see, we are lucky here because there is no RS. Otherwise, VBE has to, we should use the voltage divider rule. We don't have RE here, and that is the simplest configuration in common emitter amplifier. So that's the first part. Second part, we have to find the input resistance and the output resistance. So I'll use the same circuit here. Rn is equal to, so what you can see from here to ground is this in parallel with that, is RB in parallel with RBI. So this is equal to RB in parallel with RBI. RBI, we should know it from the DC analysis. It is beta over GM, right? And the second is R out. Now to find R out, we have to deactivate the input. If the input is voltage source, deactivating it, it means we have to short it out. So we short this. When you short this, now VBE will be 0 because there is nothing here. If VB equal to 0, this dependent source will be 0, so it is open circuit. And what we can see from here to ground only RC. So the output resistance of this amplifier is RC. Okay? So you can see this basic structure. It is easy to analyze it. Now, what will happen if there is a resistance RE here, let's say, right? So our circuit now, if the ammeter is not grounded, then it is easier to use the T model. Of course, you can use bi model simply by including RE here, right? So if we include RE here, now we have to name this potential VE, and we have to do the analysis. Again, it is circuit analysis. V out will be the same. It will be minus IC into RL dash, but to find VBE, we have to be careful here, right? To find the relation between Vn and VBE, we have to be careful because we have to find what is the current here, IB. So VBE will be IB times R by, right? Now, IB will be VI minus VE, and VE will be IE times RE, right? So we have to do the analysis here. We have to be careful about this. This is one way to do it. And the same thing applies here. So Rn will be the same, R out will be the same. But to find Rn, it is not RB in parallel with R by because we have something here. And this is not in series with this because this IE will be GMVBE plus this. So they are not in series because if they are in series, they must have the same current. But I suggest that when you have RE or the ammeter is not grounded, let's say we may have an input from here, as we'll see in common base amplifier. If you have RE, it is easier to use the T model. So in T model, we'll have, call this alpha IE, let's say, or GMBBE, or whatever you want to call it, or beta IB, right? Then we have here a small RE, that is transistor parameter. So this is the emitter, base, and collector. So this we can call this GMBBE, there is no problem. We can call it alpha IE, that is also, again, it is IC, so same thing. Now we connect the rest. From the ammeter, we have RE to ground, that is RE. And from the base here, we have RBB, same as that one, or RB we call it. And then we have our input VI. And from the output here, we have RC and the load RL, and that is V out. So this is R out again, and this is Rn. And we can do the analysis. No, VB is the volt here. IE is this. Now we can do the same thing for the gain. So what we can do here, we can combine these two.